Today's topic is about prime factorization. This maths is intended for grades 4 and 5. So the simplest solution for solving the prime factorization is by using factor 3. So I have here number 1. Okay, factors of 100 are 10 times 10. And then break this 10. This will be 2 times 5 times. Break again this 10. This will be 2 times 5. Then I could write this one 2 times 2 times 5 times 5. Or in exponential form, it could be 2 raised to the second power times 5 raised to the second power. So I had a conclusion for number 1. The prime factors of 100 are 2 times 2 times 5 times 5, or I can write in exponential form, this will be 2 raised to the second power times 5 raised to the second power. So that's for number 1. Now let's move to number 2. So I have here 328. 328 factors are 4 times 82. And then break this one. Factors of 4 are 2 times 2 times, how about 82? We know that 82 can be divided by 2. So 8 divided by 2 is 4. Then multiply, this is 8. 8, take away 8, it will be 0. Bring down 2. So 2 divided by 2 is 1. Times 2, that will be 2. Then subtract, that will be 0. So this will be times 2 times 41. And we know that 41 is a prime number. So the conclusion must be the prime factors of 328 are 2 times 2 times 2 times 41, or could be form of exponential. This will be 2 raised to the third power times 41. So that's for number 2. Now let's move to number 3. Number 3, 625. As we know that we can multiply, or factors of 625 is 25 by 25. And then we can break 25. This will be 5 times 5 times, break this one 25, 5 times 5. So therefore, the prime factors of 625 is equal to 5 times 5 times 5 times 5. Or in exponential form, this will be 5 raised to the fourth power. Okay, let's move to number 4. Number 4 is 4,920. Okay, since the last digit is 0, this is to recall our divisibility rule. So if 0, this can be divided by 2. So 4,920 divided by 2. So 4 divided by 2 is 2. Then multiply, this is 4. 4 take away 4, that will be 0. Bring down 9. Since 9 is an odd number and my divisor is even, so estimate how many 2 do I have in 9. So this will be 4. 4 times 2 is 8. Then 9 take away 8, that is 1. Then bring down 2. Now, the same 2 of them, 12 and 2 are even numbers. So we can divide. So 12 divided by 2 is 6. Then 6 times 2 is 12. So 12, take away 12, that will be 0. Bring down 0. 0 divided by 2 is 0. And then multiply, 0 times 2 is 0. So I have 2 times 2,460. The same, the last digit is 0. We can divide by 2. So 2,460 divided by 2. So 2 divided by 2 is 1. 1 times 2 is 2. 2 take away 2, that will be 0. Bring down 4. 4 divided by 2, that is 2. Then 2 times 2 is 4. 4 take away 4, that will be 0. Bring down 6. 6 divided by 2 is 3. 3 times 2 is 6. So 6 take away 6, that will be 0. And 0 divided by 2, that will be equal to 0. Then multiply. So I've got 0 minus 0 is 0. So I can break this one. 2 times 1230. Now, I could divide this one by 2 again because the last digit is 0. So 1230 divided by 2. So use these two digits. So how many 2 do I have in 12? So this will be 6. 6 times 2 is 12. So 12, take away 12, that will be 0. Bring down 3. Since 3 is odd number, while my divisor is even, so I just estimate how many 2 do I have in 3. So this will be 1. 1 times 2, that will be 2. 3 take away 2, that will be 1. Bring down 0. So I have here, my new dividend is 10. And 10 can be divided by 2, that is 5. Then 5 times 2 is 10. Take away, that will be 0. So I can break this one 1230 by 2 times 615. So 615 is divisible by 5 because the last digit is 5. So I could divide this one by 5. So 6, this is 1. So 1 times 5 is 5. 6 minus 5 is 1. Bring down 1. So I have here, my new dividend is 11. So I could divide this one by 2. Estimate. So this is 2. 2 times 5 is 10. 11. Take away 10. That will be 1. Bring down 5. So my new dividend is 15. Now I could divide this one 15 by 5. That is 3. 3 times 5 is 15. 15. Take away 15. That will be 0. So my factors of 615 are 5 times 123. Now 123 can be divided by 3. So 123 divided by 3. So I will use these two digits. So 12 divided by 3 is 4. 4 times 3 is 12. Then 12 take away 12, that will be 0. Then bring down 3. So 3 divided by 3, that is 1. 1 times 3 is 3. Then 3 take away 3, that will be 0. So the factors are 3 times 41. Since 41 is a prime number, so I can have my conclusion. The prime factors of 4,920 is, so I can write in here. So it's better in here because there's space. So 20 is equal to 1, 2, 3. So 2 times 2 times 2 times 5 times 3 times 41. Or in exponential form, to make it shorter, so I need to make an exponent. So my base is 2. Then how many 2 do I have? 3. So 2 raised to the third power times 5 times 3 times 41. So that's for number 5. Now let's go to the last number, which is number 5. Okay, number 5, 480,000. I need to factor this one. So factors are 48 times 10,000. And then factors of 48 will be 6 and 8 times. How about 10,000? So this is 100 times 100. Factors of 6. This will be 2 times 3. How about 4? 2 times 4. Times. So this will be 10 times 10. Times this one. 10 times 10 also. So I need to break 4. 2 times 2. Times. 10 is 2 times 5. How about this one? 2 times 5. This one also. Times 2 times 5. Times this one. 2 times 5. So I will combine all the 2 that you have in my factors. So this will be 2, 1, 2, 3, 4, 5, 6, 7. So let's say 2, 2, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then how many 5 do I have in the factors? So, by the way, there is 3 in here. Then 5, count how many 5s? 1, 2, 3, 4. So this will be 5 times 5 times 5 times 5. So to make it shorter, this will be 2 raised to the power of 8 times 3 times 5 raised to the 4th power. So therefore, my conclusion is the prime factors of, can I erase in here? 480,000 are 2 raised to the 8th power times 3 times 5 raised to the 4th power. So that's all for today's topic.